So thank you, Rachel, and hello, everyone. Today, you're going to be hearing a lot about boxes. You're also going to be hearing the word boxes a lot. So I don't know, maybe if you want to do a drinking game out of this, it could be fun. But as Rachel said, my name is Jing. I go by Jing as well. And because I'm a lover of emojis, I'm going to use them to introduce myself. I was born in Malaysia, and Rachel already explained this part about how I got started in the web. I sometimes write articles about the web, and I speak about the web, and I also happen to be a Mozilla Tech Speaker, which is an initiative by Mozilla that supports technical evangelists in regional communities around the world by providing resources and funding. Now, I met Lara Schenk at CSS EU about 2 weeks ago, and she said this in her talk, that CSS developers are programmers of boxes. And I found that a really apt description of what we do. The visual web is made up of boxes. Many different types of boxes. Boxes nested within other boxes. And all these different boxes happen to behave differently. And in order to make sense of how to arrange them, or align them, we must first understand them. So where do these boxes come from, anyway? Well, they come from CSS. CSS has come a long way since 1996, starting out as a simple style sheet mechanism allowing authors and readers to attach styled HTML documents. Today, CSS still does that. It is still a language that describes the rendering of HTML in various media. But the vocabulary of CSS has expanded immensely. I'll admit, I wasn't old enough to experience the web before CSS was invented, because the first browser I ever used was Netscape Navigator 4. Back then, I used it to search for Magic the Gathering stuff, never mind. But I'm very glad that CSS was invented and has evolved to what it is today, and that the web is not a giant fax machine. And like I said, before we can talk about box alignment, we need to talk a little bit about the boxes themselves. So out of curiosity, I'd like to ask how many of you read CSS specifications? If you are a member of the CSS working group, please remove yourself from this survey. Thank you. Great, this is just the number I was expecting from this audience. And this is a screenshot of section 4 of the CSS1 recommendation published in '96. First of all, can I just say that I love the ASCII diagrams on this document? And also, doesn't that textured background just make you smile? The box model has been around since the earliest days of CSS, grouping all rendered elements into 2 categories of boxes, block level and inline. Fun fact, upon further perusal of this document, I discovered that at the time, CSS was not meant for doing layout. Just a little something to think about. CSS2 had expanded this formatting model, which is what we now know as the visual formatting model. This is the model that determines how user agents process the document tree for visual media. And one particular sentence in the specification stood out to me when I first read it. It read, in the visual formatting model, each element in the document tree generates 0 or more boxes according to the box model. How do you generate 0 boxes? That sentence out of context seems somewhat bizarre, but once I learned a bit more about how browsers worked, it started to make a little more sense. Rendering engines pass the source document into objects the browser can understand, but before it can actually render anything, an intermediary structure called a box tree is generated. This is a representation of the formatting structure of the document, and CSS will assign a computed value for each CSS property to every element and text node in the source tree. One of those CSS properties is display, which tells the browser what type of box to generate. So usually it's a one element, one box kind of situation, but some values can generate more than one box, like say list item, which generates a principal block box, and a marker box for the bullet. And then we have values like none, which cause the element not to generate any boxes at all. So that's the generate 0 boxes bit. Cleared that up now. So after the browser generates the boxes, it'll have to lay them out. And the layout of these boxes are dependent on several factors. We have the box dimensions and type, the positioning scheme used, relationships between elements in the document tree, and external information like viewport size, intrinsic dimensions, and so on. So let's talk positioning schemes first, because there's some terminology introduced here that pretty much sets up the remainder of the talk. So there are three types of positioning schemes. We have normal flow, floats, and absolute positioning. Boxes in a normal flow belong to a formatting context. And right now we have several of those. Relatively positioned boxes remain part of this normal flow. But when we float a box, it is first laid out in the normal flow, then taken out of it, and shifted as far left or right as possible. When a box is absolutely positioned, it's removed from normal flow altogether and given a position with respect to its containing box. So a formatting context is the environment in which a set of related boxes are laid out. And different formatting contexts have different rules for how they lay out the boxes within them. Boxes are capable of generating new formatting contexts, creating a new environment where the layout of its children is mostly not affected by the rules and contents of the environment outside itself. Now, I say mostly because certain formatting contexts can allow interaction between their contents, like line boxes in an inline formatting context can interact with floats belonging to the block formatting context containing them all. Which then brings us to the display property. The CSS display module level 3 is meant to replace and extend the display property from CSS 2. Some of the things I mentioned may not be implemented in browsers yet, but do paint a picture of future CSS to come. So it used to be that a single keyword syntax for display was enough because we only had block boxes, inline boxes, and table boxes, and they could pretty much exist in the world on their own. Flexbox was the first module to introduce the concept of a parent-child relationship between a box and its children. Now Grid does that as well. In display level 3, the single keyword syntax is still very much valid, but each of these values have a longer, full version that indicates how the box itself behaves and how its children behave. There's the inner display type, which determines the type of formatting context the box generates, and this affects the child boxes within it. And then there's the outer display type, which dictates how the box itself participates in the flow layout. So this table I directly lifted from the spec, a lot of stuff on it. I've split it across 2 slides. We're not going to go through them all. But notice that the outer display property is either block or inline. Now, I'm glossing over run-in for now because its implementation status is iffy at the moment. I think it's been iffy for about 20 years. But there's a part of the specification that is relevant for browser vendors, probably not so much for web developers. But it's good to know that explain how certain layout effects require the blockification and inlineification of box types to ensure a box is matched to its context. As far as I know, the multi-value syntax is not supported in any browser yet. I've only managed to find an entry for it on Firefox's bug tracker and none from the other browsers. But if someone here can verify this for me, I'd appreciate it greatly. Out of this long list of values, though, only flow root is a brand new value. When a box has its display set to flow root, it generates a block-level block container, practiced that a lot of times, that establishes a new block formatting context. So a block formatting context, which I will abbreviate to BFC to make my life easier, is the context that block-level boxes participate in. Boxes are laid out one after another in the block flow direction, which is determined by a box's writing mode. Margins along the block flow direction between boxes within the same BFC will collapse. This is otherwise known as the infamous collapsing margins phenomenon. Earlier I mentioned that when a new formatting context is established, boxes within this new context are largely shielded from their outside environment, which can come in pretty handy sometimes. So there are a number of ways to establish new BFCs. You can float a box, or position it, absolutely. If you make the box an inline block, a table cell, or table caption, that can give you a new BFC. You could set a block box's overflow value to anything but its initial value of visible. And lastly, the new way to do it, display flow root. So what good is a new BFC? Well, I'm glad you asked. Remember that I mentioned a new formatting context will generally contain the boxes within it. Well, if collapsing margins isn't your thing, then maybe this might help. Fingers crossed that this doesn't go badly for me. So here, both the green and orange boxes have a margin of 0.5 ems, but the top margin of the first box and the bottom margin of the second box has sort of collapsed into their parent. So making the parent a new BFC will solve this problem. So any of the methods we mentioned earlier will work here. So let's try a commonly used one, overflow hidden. And you'll see that this margin collapse problem disappeared. And right now, both the green and orange boxes are in the same BFC. But if I apply display inline block to the green box, oh my, I can barely see. I can't read what I'm typing. I'm going to... Oh gosh, okay, this was not the greatest idea I had. But because it's now a new formatting context, this whole margin collapse problem magically goes away. So this next example is exactly the situation I described earlier, where contents within two formatting contexts sort of end up interacting. And to prevent the line boxes from sort of poking into the space below the floated box, we can make the P element wrapping the text a BFC. So here, let's try a different method. Let's try overflow auto. Should have practiced my typing before I started. But as you can see now, the text sort of stays in its own lane. And it's probably not the most semantic thing you could do in your life, but if you set this to display table cell, it sort of works as well. Because it generates a new BFC, just to prove a point. And we've essentially made the float and the text belong to separate formatting contexts. So their contents are sort of contained within their own environment, so to speak. And lastly, this might be the most common use case for establishing a BFC as a technique for containing floats. Sometimes we say clearing floats, which is fine. So this situation happens when all the items within a container are floated. And the parent container sort of ends up with no height, so it's like a flattened purple thing at the top. This is because the floats are now no longer in the normal flow, and they no longer affect the height of the parent. So establishing a new BFC will sort of resolve this problem. Let's do the new thing, display flow root. And you can see that the parent box now wraps its children nicely. You can even see the pink background. Another option is actually to make the parent float as well. I don't think that there are a lot of use cases where this will work, but as you can see, it does. It does give the parent a height, but it'll just end up wrapping all the children. I don't know, maybe that's something that you want. Now, if block-level boxes do block formatting contexts, then naturally, inline-level boxes will participate in an inline formatting context, which I will also abbreviate to IFC. Now, the rectangular area that contains the boxes which form a line is referred to as a line box. You can think of a paragraph as a stack of line boxes. Now, line boxes are a bit tricky because we can't directly see them from the source. They're generated based on how the content needs to be laid out. So this is an example of a block box that contains 5 inline boxes, the block box in this case being the P element. For now, there's enough room to fit all 5 boxes into a single line box. But when there isn't enough room, inline boxes can be split across multiple line boxes. So let's do that. Let's just make the font large. Larger still. OK, this is nice. So splitting an inline box is like slicing a Snickers bar. The cut part is not going to have any chocolate coating on it. So margins, paddings, and borders don't apply to the split part of the box. So let's see how this works. If I do margin 0.5 m, you'll notice that movement only happens along the inline axis. The distance between the line boxes don't change. Same goes to, oh wait, why am I doing this? I have a mouse. Padding, same thing. And the thing is that padding does apply all around. So let's put a background color so you can see. I'm going to use lime green because I like green. See, even though the padding applies all around, the cut part doesn't apply. The distance between the line boxes doesn't change, but the backgrounds still overlap. And I know this may seem like a situation that you don't want to have, but I don't know, there could be some interesting things from a design perspective that you could try out here. I mean, let's see. We could do the same thing. Okay, somebody used tomatoes, so I'll use salmon. And you know, it's kind of fun. You could do something weird, like maybe mix blend mode. Nowhere near as complicated as what Sarah explained, but I don't know, it could be some designy. Up to you guys. Possibilities, my friends. And now that we're better acquainted with line boxes, it's alignment time. So to align them along the inline axis, things are reasonably straightforward. We use text align. So you can do left, you can do right, you can do center, you can do justify, so many options. Just note that there has to be excess space within the line box for this to happen. Also, text align only comes into play after all the required line boxes have been generated and all the line boxes have been laid out accordingly. So alignment actually happens after all this rendering has been done. A line box will always be tall enough to contain all the boxes within it. It can even be taller than the tallest box it contains. So shorter line boxes can be aligned along the block axis with the vertical align property. Now, vertical align is one of those properties that trips up people who are new to CSS, because it's only applicable to inline level and table cell elements. But come on, there's no way you'll know that if you just read it at face value, right? You're expected to vertically align stuff because that's what it says. And it's key to remember that vertical align controls the alignment of inline boxes within the line box and not the alignment of the line boxes themselves. And the height property does not apply to inline boxes. Sometimes I feel like CSS wants to play tricks on people who are new to it, but never mind. The height of an inline box is actually determined by their font size and their line height. And here's where the spec gets a bit laissez-faire about things, because user agents are free to decide if they want to use the M box or the maximum ascender and descender of a font to calculate this value. So you can use absolute length values like ems or pixels to set the height of an inline box, but we can also use unitless numbers. And the browser will multiply this by the element's font size to get a computed value. If you use a percentage for line height, it will also be multiplied by the element's font size, not the height of the parent element, which is generally a more typical resolution for percentage values. So just something to keep note of. So let's have an illustrative example. Before Flexbox became widely adopted, there were a number of techniques for centering things along the block axis. So one of them was this inline block technique I first discovered from a CSS Tricks article by Chris Coyer called Centering in the Unknown. It involves aligning the target block with a pseudo-element that is as tall as the parent container. Now, an inline block is an inline-level block box, also known as atomic inline because it participates in an IFC, but as a single opaque box. Now, setting both the pseudo-element and the child box to inline block means they're both in an IFC. Because the pseudo-element is as tall as the wrapper, the vertical align property can be used with a block of text. So it might be easier to visualize this, and we can do that, give it a color of lime green and a width of 1 em. So that's what the text box is actually aligning itself to. Moving on. And now we move on to one of the newer formatting contexts, the flex formatting context. So different formatting context, different set of layout rules. So some of the highlights of the Flex layout model include the fact that the Flex container's margins will not collapse with those of its children. Float and clear do not apply to Flex items. Vertical align, no effect on Flex items either. Flex items can still be taken out of flow with absolute positioning, and Flex items are Flex-level boxes, not block-level boxes. So I've been using the terms block direction and inline direction for the entirety of the talk thus far, and now I'm going to introduce a new type of direction called the Flex direction. Think of Flex direction as the direction which Flex items flow. Now, Flex layout is fun, because Flex items can flow in any physical direction, depending on the Flex flow, Flex wrap, and writing mode values of the Flex container. Now, the main axis is the primary axis which Flex items are laid out, whilst the cross axis is always perpendicular to it. So Flex items are laid out within Flex lines. Now, these containers are a little bit similar to line boxes in that you can't see them in the source, but they are used for the positioning and alignment of Flex items. And we can have single line containers or multi-line containers, depending on the Flex wrap property. A single line Flex container will lay out all its children in one line, even if that means an overflow. And this is the default Flex container behavior if you don't explicitly set a Flex wrap value. Setting it to wrap will cause Flex items to break across multiple Flex lines, and additional lines will be stacked along the cross-axis. The direction of this stacking is affected by all those factors that I just mentioned. So, illustrative example again. So all these right now are default values except wrap. So we have 4 options for this. We can do a row reverse. So you can kind of see the numbers, right? So these are indicative of how things are flowing. Row reverse, it's from the other direction. But of course, you can also have, why only have horizontal when you can have vertical? Okay, for this to work, we need to set a height on the container. Let's have an arbitrary value of 50 VH. Yeah, something like that. And of course, you can reverse. So if you don't want it to go up, down, you can reverse it, and it becomes from down to up. And this is something you don't really see very often on the web. You don't see things starting from the bottom of the page, but I mean, possibilities. And now if we do a wrap reverse, now 1 starts from the other side. And because these properties sort of interact with each other, those of you who are mathematically inclined can start to calculate the possibilities. So let's kick everything back to a more default situation, because we also have vertical writing modes. And this, you end up with, yes, columns, but again, the order of things are different because vertical RL means things flow from right to left. But there's also LR. And then, in writing mode level 4, which is only implemented in Firefox for now, there's also this value called sideways. So really, many possibilities. So many possibilities that I also wanted to point out that there are things known as right-to-left languages, so just multiply everything by 2 and voila, 64 potential combinations. And I don't know if you're bored one weekend and take the time to try out every combination. Don't worry, you won't get 64 different results because a number of combinations do end up giving you the same end result. But these writing modes will affect the text within your Flex items, so I don't know, a lot of fun for your weekend. Okay, alignment time. So Hida already showed us how easy it is to align things with the newer layout modes, and I'm going to build on that. Also, thank you, Hida, for the mention. Really appreciate that. Now, I'm going to start with something that is somewhat direction agnostic. So for Flex layouts, margins are distributed before alignment properties kick in. So any positive free space will be distributed to auto margins in their respective dimensions. So let's say I do something like set a margin left on boxy here, it immediately ends up on the other end of the container. And if I do something like margin top, Boxy just gets sent all the way down. And if we don't specify a dimension, then any free space will be equally distributed on either side of the flex item. And I love showing this example to people who have just started out with CSS and have sort of ran into a wall when they try to center things. So I'll just, hey, have you heard of this thing called Flexbox? And then they're like, what's that? And then you go, margin, auto, boom. One-line solution to all your centering problems, and then you just quietly tell them, caveat, works best if you only have one flex child. Now, this is one of my all-time favorite talks by Elika Etamat, aka Fantasai, at CSS Day on this stage 3 years ago. And in case you missed it when Hida mentioned it, she works on CSS specifications. Almost every CSS specification, actually, and is one of the few people in the world that can answer any question you could possibly have about them. And this is where she defines this mystical value in CSS known as auto. So this talk is definitely worth watching. Now, for the most part, we're going to have multiple flex items within our flex container, and they will need aligning as well. So we have 4 alignment properties at our disposal when it comes to Flexbox. Justify content helps distribute free space left over after flexible lengths and auto margins are resolved. So like this space I have here on the right, it's not quite 5em, so it's just a space there. So the initial value for this is a flex start, but we can position content with flex end, and somehow centering things is really popular in web design. I can't understand why. And that's for content. That's for positioning content. But you can also distribute space between the flex items using the space distribution properties. And we have 3 of those. We have space around. Oh, this is terrible. You can't really see. But there's a difference. Trust me. Space between and space evenly. So the difference is just in the amount of space between the flex items. So here's some illustrations to show how the values work. I'm missing space evenly because it's reasonably new. Supported only in Firefox 52 and Chrome 60 onwards. By now, it's considered current, so OK, you can use space evenly. Be safe. So the next thing is to align along the cross-axis. And here we have flex children of various heights, so there is space within the flex line for them to be aligned. Align items sets the default alignment for all flex children at once. And the initial value, again, is flex start. But of course, we can do the typical flex end and center, because everybody loves centered things. But we can also stretch out the children to fill up all the available space. But then you see that your text kind of ends up very jagged, and some people don't really like that. So an option you could try is baseline, which lines up all the text lines rather neatly. Now, if we want to tweak positions of individual flex items, we can do that too. And we'll have to make use of the align self property, which does the same thing, but for a single flex item. So if it's applied to a class, then only those with that class will get affected. Let's just do a flex start. So you can sort of customize the positioning of your flex items with these properties. Really, really useful. Another bunch of illustrations to show how things work. I really didn't know what to do about baseline, so this is it. Sorry. Where's my mouse? Keep going. Now, I lifted this header directly from the specification because it's so descriptive, because you're literally compacting the flex lines, right? So if a flex container has more space along the cross-axis than necessary to contain all the flex children, the flex lines stretch to fill up all the space. I emphasize flex lines and not the flex children themselves. So the property that controls this is align content. So only multi-line flex containers will ever have free space along the cross-axis for us to do alignment stuff. Flex lines in single-line containers, by default, just stretch to take up all the space, so irrelevant in this case. Now, if we don't want the default value of stretch, which can sometimes cause unwanted behavior, like this weird spaces between my lines, we can pack the flex lines and position them accordingly within the flex container. So I think by now you'd know what values are used. So we have flex start, just shoves everything up. You can do flex end, shove everything down. And similarly, you can also distribute the space if that's something that you want, but more evenly with the standard space distribution properties. And if there is one thing to take away from this talk, everything else you can't remember, it's fine. One thing to take away is that you can only align stuff if there's extra space available in the container box. So if you sometimes just try out all these alignment properties and nothing is moving, maybe you just don't have space. Just something to think about. Now we're going to move on to what is arguably the hottest in CSS layout these days, grid. So the layout rules for grid formatting, the grid formatting context, somewhat similar to that of a flex formatting context. You can think of them as like cousins. The grid container's margins also do not collapse with the margins of its children. Float and clear don't really do anything for grid items. Neither does vertical align. And grid lines are what form boundaries of each grid item's containing block. So these are the terms we always refer to when we discuss CSS grid. Grid lines are referred to by their numerical index, which starts at 1 and not 0, because why not? And you can also use a negative index for easy access to the last line in your grid. You can even name the grid lines if that's what you want. Eventually, the CSS working group decided that it made sense to come up with a cohesive and common box alignment model that could be shared across all the different formatting contexts, because who knows, there might be a new one coming up eventually. So that's the CSS box alignment module level 3. And they define the 6 properties that control alignment of boxes within other boxes. CSS Grid uses all 6 of them, whereby Flexbox only uses 4 because justify self and justify items do not apply to them. Now, in the future, these box alignment properties will be applicable to block formatting contexts as well, which will make alignment a much more straightforward process than what we know now. So justify content and align content properties are known as content distribution properties. And we've already seen them in action in a flex formatting context. So this table is a summary of the values we've covered thus far. Question: how many people have trouble remembering which value affects which axis, like justify versus align? Yeah. Follow-up question: has anybody here not used Microsoft Word or any form of GUI word processing software? Okay, good job, Microsoft. So here's how I remember them. Almost every word processing interface I've ever used in my life have these 4 icons that let you justify text, right? And if you think, justifying text moves it along the direction of your text. So by process of elimination, align must move it along the only other direction available. So this is a personal trick of mine I've never forgotten. Maybe it'll work for you, maybe it won't, but yeah. The values we've covered for Flexbox are applicable for grid as well, except that instead of flex start, we'd use start instead. But if you do end up using any flex prefixed values in a non-flex formatting context, the browser will resolve away the prefix. So let's just verify that you actually can do that. So ideally, you want to use end, right? But if I use flex end, hey, it sort of works too, because, I don't know, browsers are smart like that. But you're free to use start and end for Flexbox, though. And now we've sorted out the align versus justify situation, I want to bring your attention to a shorthand for setting both values in a single declaration. And this shorthand uses the word place. So let me just replace all of it, pun not intended. Place content. The first value is for align content, while the second value is for justify content. So if I do end center, whoa, what happened? Okay, let's just do end space around, because that sort of works too. If you only enter a single value, though, let's just do center, then the justify content value will just default to the first value. And there's a rendering issue, but it's right smack in the middle, so just trust me on this, okay? Now, the justify self and align self properties are known as self-alignment properties. I love how the spec names things very descriptively. Now, these properties allow us to control how the content of each grid item is aligned within the grid area it's been allocated to. And the default state is stretch, like A is demonstrating, where the content stretches to fill the entire grid area, but we can adjust the alignment of content within the grid with start, center, and end. Once we apply any of these values, though, the grid item will shrink to fit its contents along the respective axis of alignment, and the place self shorthand is also available here. Finally, we have align items and justify items properties, which set the default align self and justify self behavior of all the items within the grid. Similar to Flexbox, except that justify items does not apply to Flexbox. And you can always use place items if you very much prefer a single line declaration. Now, alignment keywords or values that we use in these various alignment properties can be classified into 4 categories, and we've covered a lot of them. We've covered distributed alignment that affects the space between columns or flex items. We've touched a little bit upon baseline alignment, and we've also gone through all the positional alignment stuff as well. But there's also keywords for managing overflow. Let me explain. So if contents within a container are larger than the container itself, overflow occurs. And that's when we get scroll bars, depending on the value of overflow. But there will be instances like this one here, where the alignment mode sends part of the box past the viewport's start edge, where you can't even scroll. I can't scroll to get to it. It's just chopped off. So to exercise some semblance of control over such behavior, we can make use of 2 keywords, safe and unsafe. And so if I set the safe keyword here, what it does is that it will override the alignment mode and make it behave like start in an overflow situation. But if I insist, like I don't care that people can't read the top of my content, it's a design decision, sure. You can use unsafe, which appears to be the default behavior now. But I believe that moving forward, browsers will use safe as the default behavior. Okay, so I really loved Hide's talk, which showcased so many great examples of graphic design that we can draw inspiration from. So this is my contribution to that list. This is a page from Laszlo Molinage's book, Mallory Photography Film. I'm butchering the pronunciation, but it's a pretty classic griddable design. I like to use the word griddable here, because when I first saw this poster, I was like, this is definitely something that can be built with CSS, right? It's a striking design. It has these bold black borders. The content is aligned in all different directions within their respective grid cells. So here is where all the alignment properties that we've just talked about come in really handy if we want to recreate a design like that on the web. So the code shown here is sort of abridged to show just the layout code, but even the gear and the arrow can be made with pure CSS, with some help from the box shadow property. But in order to align the inline content of each grid child without disrupting the rendering of those thick black borders, we'll need to make each grid child itself a flex parent. Because by default, the value of a grid item's alignment is stretch, where it fills up the entire space of the grid cell. But once we apply alignment properties to the grid item's contents, it will shrink to fit and sort of screws up your borders. So making each grid item a flex container allows us to use box alignment properties to adjust the position of the grid item's content while keeping the borders at the edge of the grid cell. So you can actually, that's the effect that we actually want for that poster earlier. So when I started preparing for this talk, I wasn't really sure how much I could talk about box alignment, but that was because I hadn't really dug into what box alignment was all about. And the more I dug, the more I realized that, hey, wait a minute, hang on. I'd been using all these techniques all this while without really understanding how they worked. Now, I barely scratched the surface. There's a way lot more that I just shoved out of the talk because, time. But I don't know about you, but this has been a great experience for me. And I do hope you find some of the things that I covered useful to you, and that you enjoyed this talk as much as I enjoyed giving it. So here's a long list of links and resources, and thank you all for your kind attention.
Thank you, and join us over here. So yeah, there's an awful lot you can talk about alignment, really, isn't there?
Yes, I just found out that, yes, I could go on.
Yeah, there's so much really, really neat stuff. We had a question. I'm not actually quite sure if I'm asking the exact question that the person, but I think what they wanted to know really was about transitioning the alignment of things. How can we transition between two states, maybe change the alignment to a new direction without having to start absolutely positioning everything?
I believe at the moment, you can, well, it is planned that grid items can be animatable, but at the moment, only grid gap is visibly animatable in probably Firefox.
I think it's only Firefox.
In the spec, it does say that grid items are supposed to be animatable.
Yeah, grid track should be able to animate, but yes, nobody does that.
So with a little bit of patience, you never know, you could actually, I don't know, canonically animate your stuff across the grid, which is great.
Yeah, I mean, the thing with animation is things have to have that in-between state, which not all of this stuff has.
And maybe like what Greg said, you could use the new observables to, I mean, we can't just get rid of JavaScript altogether. We just need to know how to use them together in the most performant ways.
So anyway, you're obviously very excited about alignment. I totally get that. What is coming to CSS that you are thinking, yes, that's going to make a big difference?
Well, I'm pretty interested in the containment module, because it's also a bit related to the animation question. Because what containment does is that it can sort of, I don't know if I'm saying this right, but it can sort of isolate a particular element, and you can sort of tell the browser that, hey, I'm actually only this bit here, this element is going to have any changes. Just leave the rest of the stuff alone, and then you can, I don't know, you could animate it, or you could do stuff to it, and the browser doesn't have to render all the other stuff that evidently is not changing. But as of now, how browsers work is that you change one tiny little corner of your website, the whole thing has to re-render, repaint itself. So that is pretty interesting. And
it's those little practical things. I like those.
Yeah. It's not fancy. It's one of those utility things that you didn't know you needed, and when it's working well, you don't think about it. But when it's broken, you're like, something's broken.
Yeah, that's very cool. Well, thank you very much. It's been great, and I learned things today, so thank you very much.
Thank you.
Here you go.